Thank you. So today, basically, we are trying to talk about two main problems. First is scalability, and the second is how you can use AI-driven, or you can say spec-driven development into your infrastructure. So before we start, I would like to give two scenarios that I came across. First scenario that is publicly available in 2012, Netflix engineers were facing a lot of challenges, massive challenges to manage their thousands of resources, right? Because of there was no automations. So what they did is they built a Spinnaker and infrastructure as a code automation to manage all this infrastructure. But again, at that time, they had to write all this infrastructure as a code manually, right? It requires a lot of skills. It also includes a lot of human errors, right? Because you have to write all this infrastructure as a code manually, right? A lot of challenges. But what if I told you, like, if as a developer, we gave a capabilities where you can just describe your intent to your GenAI, and GenAI will do that do the transformation from spec-driven to the Terraform production-ready deployments, right? So today we will talk about how you can actually transform your Terraform infrastructure deployment using the spec-driven approach. The other scenario that I wanted to give is 2 years back I was working as a DevOps, and one of our customer was doing a lot of scalabilities across the multiple region, multiple environments. And what they were doing, their development team was actually copying their Terraform configurations multiple times as per the requirement of multiple environments, multiple regions. But that was not a scalable, right? So we'll try to solve both the challenges with this spec-driven approach. So with that, first I just tried to introduce myself in a Terraform way. My name is Dr. Rahul Gaikwad, and just to clarify, doctor is because I have PhD in artificial intelligence in IT operation. I am not a doctor of from medical background. Currently, I am working as a staff resident solution architect at HashiCorp, which is owned by IBM. I have almost 15 plus years of experience. I also acted as a HashiCorp ambassador, and I have capabilities around DevOps, cloud, GenAI. So I would like to introduce Pranit.
Hello, mic check. I'm audible, right? Thanks, Rahul, for your introduction. Myself, Pranit Raje. I'm working as a solution architecture specialist at HashiCorp, an IBM company. I have total of 7+ years of IT experience, totally in DevOps, cloud, Kubernetes, and stuff. So yeah, over to you.
Yeah, thank you. So what we'll do is we'll try to keep you awake with a couple of scenarios and one of a real world demo as well, right? That Pranit will show you. So we'll start with infrastructure complexity crisis. What are the current challenges which our customers are facing? Then we'll talk about what is the spec-driven development, right? And how you can actually use that methodology into infrastructure development. Then we'll quickly introduce with Kiro, as well as we'll talk about the Terraform stack, which recently launched. Then we'll talk about how you can convert your specs requirement into production-ready stacks deployment. And we have a nice demo where we will do a multi-environment deployment using the Terraform stacks. And then we'll summarize with the takeaways. So let's talk about the infrastructure complexity crisis, right? So last month, HashiCorp has done a research around 1,000 plus customers. And what they found is almost 52% customers are having a cloud complexity as a top challenge in managing their infrastructure. Most of the organizations are using more than 5 tools, services to manage their infrastructure, right? And 58% organizations are using a hybrid cloud setup. So you can imagine how much complexity is involved, right? So before we start about talking about the recent trends about the spec-driven or maybe AI driven, let's try to understand how our infrastructure as a code evolved over the time. So this is the timeline. You can see in early 2000, we used to do a infrastructure provisioning using the CLI or manual method, right? Maybe a graphical user interface like ClickOps. Then in mid of 2000, we started automating small things using the shell commands, bash scripts, right? Then in 2010, actually we started around the configuration management using the Puppet, Shape, Ansible. I still remember those days where I used to manage my on-prem environment using the Puppet. I know how much complex it is when you manage your Hira configuration, Puppet configurations across the multiple environments. So in 2010, actually, Amazon launched CloudFormation as a cloud native infrastructure as a tool, right? And Terraform actually launched cloud agnostic infrastructure as a code tool in 2014. Then in early 2020, so we have a container orchestration platform such as Kubernetes, Docker, right? And then we slowly started evolving around the AI-driven ISC, where we launched Code Whisperer back then in 2023. Now we are calling it as a Q developer, right? So now over the time we use Q developer as a like a vibe coding tool, but over the time we saw a lot of challenges with vibe coding, right? So then we invented Spec-Driven infrastructure as a code using the Kiro. That is how we evolved around the infrastructure as a code. So what is the Spec-Driven infrastructure development, right? So it's basically a methodology, right, where you will, instead of writing the code first and then documenting, right? In the Spec-Driven, we will write the spec, our intent, and then we will do the coding, right? In the vibe coding, a lot of times what we do is we give a prompt, like it's a 10% of your prompt, and 90% your LLM or GenAI try to understand your requirement. It decides the requirement by themselves, right? Because it does not have required information in your short prompts. So 90% time, your LLM will take the decision and it will perform the actions. But in the Spec-Driven, it's opposite. 90% you are giving the instructions and LLM just follow that instructions and perform those actions like a 10%, right? That is a Spec-Driven approach. So in the vibe coding, let's try to understand what were challenges. We started with the vibe coding. Consider the scenario where one of organization having a team of developers and they were asked to write or develop an application. So they were given a very vague requirement about the application, and they started working in a team, right? They were using a different tools, different methodology, different programming languages, and they were developing that application in a different mode, right? And they, due to the timeline, they did not write any documentation around that. And when they try to integrate at the end, they were facing a lot of challenges in the integration. Because in the vibe coding, most of the development was done by LLM, not by the developer, right? So a lot of challenges around the vibe coding. So we try to overcome those challenges in the spec-driven approach. So in the spec-driven approach, you can see it's basically not a tool or technology. It's nothing to do with any specific cloud provider, right? It's basically methodology that you can follow across multiple code assistant tools, right? So you can see you will spend a lot of time in planning, designing your architecture, and then you will give that intent to your tool. Maybe it's a code assistant tool like a Kiro in this case, and we will follow the same development approach in the infrastructure development area as well. So let me introduce Kiro, how we can use Kiro to do the spec-driven development into the infrastructure specifically. So as you can see, Kiro is basically converting your concept into production ready implementation templates, right? So Kiro has a lot of benefits around the across the vibe coding because it complements to the vibe coding. It supports both vibe coding as well as the spec-driven development as well. So with that, I will just hand over to Pranit to talk about complexity.
Thank you, Rahul. Wow, quite an interesting stuff, right, with the spec-driven and Kiro. Now let's shift our gears to the infrastructure side and how the complex infrastructure has been, recommended to manage at scale. When talking about the complex infrastructure, what type of use cases come to your mind? If you ask me, I can think about 3 top major use cases. The first one starting with the Kubernetes workload, operating the Kubernetes workload at scale with having lots of interdependent components, for example, your underlying infrastructure, the networking components, your clusters, the namespaces, the Helm charts, the application itself, the CRDs, and etc., etc. If you are the Kubernetes shop, you know the list goes on and on, right? The second use case is related to the microservices, having lots of interdependent configurations or components with each other, talking to each other. And managing at scale could get really complex as well, right? And the third use case is my favorite, that is the landing zone. Just a quick check, how many of you are already aware or operated the AWS landing zone at scale? Can I get a, wow, quite a good. So when talking about the AWS landing zone, so for those who are not aware of the landing zone, it's just like a blueprint or a secure foundation of your infrastructure by which organizations can get started with the cloud services without having to build anything from scratch. So as a solutions architect from HashiCorp, when we work with the customers who are operating in AWS landing zone, we do recommend them to use the HCP Terraform, which is nothing but the commercial product of Terraform managed by HashiCorp, and it lets you run the Terraform in their own cloud with lots of benefits like the managed Terraform operations, the state management, and the workspace variables, security, and lots of things. So when you manage your AWS landing zone with the help of HCP Terraform, what we recommend our customer is to segregate your workload into individual workspaces. So what are workspaces? It's nothing but an isolated environment for your Terraform runs where you can have all of your components or all of your applications run together. It gives a lot of benefits like the management, the security and stuff. But you can see if you're operating landing zone at scale, you would be having multiple accounts, multiple environments, and multi-regions as well. So in the screenshot, you can see the ideal scenario, you would be having security workspaces, then shared workspaces, then the network workspaces, and then your applications will also have multiple environment, dev, test, prod, and obviously as per your requirement, you could be operating in multiple regions as well. While we do recommend, and this is still a best approach to operate your landing zone at scale, because it gives you that modular, composable design for your workspaces, right? It optimizes your Terraform speed, the security and maintainability, everything. But it also comes with a couple of challenges. First is the complexity. If your application is talking with a lot of different applications, right? For example, your VPC or your infrastructure is taking some inputs from your networking, your database is taking some inputs from the infrastructure side. Managing those interdependencies between those workspaces could get complex at scale. And the second is the management of that thing. While there are some couple of solutions to automate everything with the help of TFE provider, we do we have launched a new feature with Terraform, that is the Terraform Stacks. So with Terraform Stacks, it's a new approach to provision your infrastructure in a repeatable units of repeatable manner, which helps you to optimize the deployment. It helps you to automate the interdependencies between the different components, and it helps you get started quickly without any complexity. So this is just like a marketing definitions. How does Stack do that? So we have introduced a couple of new configuration layers in terms of our stack. Those are called as components and the deployment. So you can see I have defined components here. So components define the what part of your applications. So for example, what do you want to deploy? These are like very similar like the Terraform modules. So you can see I have different 4 components here in the diagram. That is the network component, the secret store, compute platform, and the database. So this is like my repeatable unit of infrastructure, which I will be deploying or provisioning in multiple environments. For example, development, staging, and the production. And obviously you can customize the variables, input variables as per your own requirement, so that you don't want to, manage the same thing, or you don't want to give the same inputs for different environment as well. So enough of the talk, show me the code. How does the components look like? It's very similar to your existing Terraform modules, where you can define your source, as in what is the source of your Terraform module, then what are the different inputs that you want to provide to my components. And you can see I have not hard-coded anything, it's just a dynamic definition, and then the standard, the providers one. So when you talk about component, I want you to remember this is defining the what part of my infrastructure. Then comes the providers. This is also again similar thing as we have been doing it so far. But here we are introducing the security best practices, so that by using the dynamic credential with the help of OIDC authentication, I'm defining my AWS provider for each of the regions that I'm operating in. So you can see I have defined some IAM roles for my web which generates the JWT tokens, and I have defined my AWS provider like that. Then comes the deployment. So deployment defines the where part of your Terraform or the infrastructure. Where do you want to deploy these repeatable units of infrastructure? So I can define multiple accounts, multiple regions in my deployments. Starting with the first stop, that is the identity token. As I said, the JWT tokens, which will be generated by your AWS as an audience. And then I have defined my development environment as well as the prod environment. And I'm passing various inputs, customizable inputs. For example, the development environment should be provisioned in US West 1 or US West 2 regions. And also passing the same JWT tokens for that regions. And if you want to introduce multiple accounts for those deployments, so for example, your development environment could be in one account, your production environment could be in another account. So everything you can define it in the deployments configuration. So what did we learn so far? Components define the what part of your infrastructure, and the deployment defines the where part. So now we have got introduced to the spec-driven development as well as the stacks. Let's see how to take those spec-driven development learnings and generate my Terraform stacks. So as Rahul mentioned, Kiro has capabilities around the spec-driven development. It gives you 2 options, like if you want to do just get started with the vibe coding, or if you want to use the spec mode, you can enable that from Kiro. And then for this particular use case, I'm using the spec-driven development. So I'm just using the spec mode here and just giving all my requirements, as in what is the multi-account, multi-region environment or setup, the infrastructure setup I want to define as a type of prompt. So you can see this is just a small prompt I have written. Like for example, I want to deploy multi-environment setup with the help of S3 and the DynamoDB into development and production environment. And I'm also helping Kiro with lots of customization what are needed for my Terraform stacks. So yeah, let's get started with so what Kiro will do, it will translate your specifications into the stacks. It will identify what are the different modules or files that I want to generate for this. So this is just like a similar workflow, the SDLC workflow that you have been operating in, right? So for example, first of all, you write your requirements, you specify all your requirements in a document, then you create your design document where you define your architecture, and then you implement this task as per the user stories, right? So these are the 3 major steps what Kiro defines that infrastructure workflow. For example, it starts with the requirement document, where it breaks down your specifications into individual requirement as well as the user stories, the acceptance criteria and whatnot. And you can see it is also asking me approval for proceed. Like let's say for example, if there is any misunderstanding between the key row and your prompt, if you want to change that, you can also do that here. Next is the design architecture. This is like my design document where all the architecture related stuff for my Terraform infrastructure, all the module structure, the repository structure, everything will be designed in the design document. And if you want to reiterate with any modifications that you want, you can do that here. And you can see in the screenshot as well, there were some modifications I wanted to do in my modules repository structure. So I gave all those instructions to Kiro, and it automatically created everything by that. Third and the final stage is the actual implementation of those tasks. So it breaks down all those designs and the requirements into small and modular tasks, and you can just fire off any of the implementation tasks from the Kiro ID itself. So now what we have learned so far with these slides, I want you to remember stacks are your new approach to provision the repeatable units of infrastructure in a multi-account, multi-region and multi-environment scenario. So you can see in the screenshot, I have started my greenfield application development, all of the infrastructure related to that, and divided into my dev and prod environment. So you can see I am passing some different the input variables for my different accounts, the dev account, prod account, and also I'm passing multiple regions as well. So enough of the slides, let's do the real world demo. So you can see I have defined my greenfield application and Kiro has generated all the Terraform stacks for that. Now let's see how Kiro can help you define or optimize your brownfield application as well. Here in the demo, I am just introducing another environment called as staging alongside my development and production environment. So you can see I have defined this development and production, and I do have that in the HCP Terraform console. And all my S3 and DynamoDB tables have already been created by Kiro. And now I'm asking Kiro to introduce another component, another deployment for my staging environment. And it is intelligent enough to identify all the interdependencies which are already existing in my brownfield application. And now it has started generating the Terraform code which is required for your stacks. So yeah, it has also given me the summary what has been added and what other minute stuff, right? So now I'm just committing it to my VCS repository. And let's see how that quickly gets deployed. So this is my HCP Terraform console. This is how it looks like when you're buying the commercial product of Terraform. And now it has started the deployment, and it has started development, production, and it has also introduced the staging environment. And if you look at the development, since there were no changes in my development environment already, it has auto-approved my deployment there. It has identified that, and then it is proceeding to the next step. So here is the approval gate. I'm just passing the message and approving the deployment, the provisioning of my staging environment. And it will take a little bit of time to, that depends on your application as obviously. Now you can see in my DynamoDB console, I have the staging table deployed already, and the S3 bucket has already been provisioned with this Terraform stacks. We're just waiting for that same successful message coming from the console. And now you can see the staging Terraform table has already been deployed. Yeah, I think that was it from the demo side. So you noticed we can generate the greenfield application as well as we can develop or improve our brownfield application with the help of Kiro as well as the Terraform stacks. This is just a confirmation check that I'm verifying the actual provisioning of those resources in the end environment. So what are the key takeaways?
Okay. Next slide. So in this 30-minute session, right? So we just wanted to give only 2 takeaways from this 30-minute session. If you are working in a multiple environments, multi-region or multi-account deployments, I will highly recommend to try out SCP Terraform stacks. That is the first takeaway. The second thing is, if you are working on any greenfield application or brownfield application where you want to handle your cloud complexity using the AI-driven or spec-driven approach, I would highly recommend to try out Kiro's specifically spec-driven approach. These are the 2 takeaways from this session I would like to highlight. With that, if you have any questions, we will be here, and if you want to connect with us, please feel free to send us the request on the LinkedIn, and you can send your query as well. If you want, you can take a photo of this. And with that, please share your feedback on this QR code. We are happy to improve and work on those feedbacks. Thank you so much.
Thank you.